Hello everybody. Welcome back to our Algebra B review. Okay, today we're looking at Objective 3, Polynomials and Factoring. Okay, polynomials is a concept that shows up a lot through the rest of the algebra course, as well as any other math course you take. Okay, so let's get good working with these. We're going to focus on their properties, how to manipulate them, as in add, subtract, multiply, and divide them. And then also, like it says here, do a little factoring. Okay, again, skills you need to have moving forward in algebra. So first things first, let's define polynomial for you. And actually, before I can do that, I actually have to define something called a monomial for you. Okay, a monomial is a real number, a variable, or a product of a real number and one or more variables. Okay, so for example, 18 would be a monomial. Okay, or the variable z could be a monomial. Or negative 4x squared, or 2.5xy to the third. These are all examples of different monomials. Okay, mono means one. Okay, nomial just is kind of the different stuff we have here. Okay, so these are individual terms that polynomials will be built up of. And then once we know what a monomial is, we can define a polynomial. I'm going to say a polynomial is either a monomial or a sum of monomials. Okay, for example, 3x to the fourth plus 5x squared minus 7x plus 1, that is a polynomial, and it's made up of different monomials just being added together. Okay, so polynomials are built from monomials. Okay, a few other pieces of vocab here for you. First one is standard form. We're going to say that when the degrees of each monomial decrease from left to right, our polynomial is in standard form. Okay, so this example here I gave you is in standard form, where we're starting off with the highest degree, the fourth degree, and then it goes down. There's no third degree, but we have the x squared, the next lowest degree. Then we can think of just the x term as x to the first. Okay, just the 1 is x to the 0. Okay, so that is standard form. Polynomials are, in a lot of cases, going to be easiest to work with when they're in standard form. We'll also talk about the degree of a polynomial. We'll just say is the degree of the monomial with the greatest exponent. So for example, here when we're in standard form, that greatest exponent is going to be our first term. And we'd say this is a fourth degree polynomial because my highest exponent among my monomials is the 4. Then last thing, we'll give a few different names for the terms, for how many terms a polynomial has. If it has one term, we'll call it a monomial, like we said. 2 terms, we'll say it's a binomial. 3 terms, we'll say it's a trinomial. Now, there's probably some other vocab words for 4 terms, 5 terms, 6 terms. We're not going to worry about those. These will be the big ones that show up for us as we go through here today. All right, now that we've got the vocab out of the way, let's get into the kind of work part of the lesson here. Like we said, working with, manipulating polynomials. Okay, so problem 1 just says write each polynomial in standard form. So what I have here in part A is just a mixed up set of monomials. What I want to do is I want to put that in standard form just to make it look nicer here. Okay, so I can say that this is equal to, I want to find my highest degree first. And I suppose also I want to combine any like terms. It looks like x to the fourth is my highest degree. So we'll write the x to the fourth there. And this one isn't too messy, but I'm going to check things off as I go, just to make sure I'm not going to miss anything. Okay, next up, there are no x to the third terms. Okay, so we don't need to say 0x to the third, but that's kind of implied for us. There's no x to the third. Next degree, x squared, I have a negative 2x squared, so I'm going to check that off as I count it up here. And we'll put that next, minus 2x squared. And as far as the x's go, I've got 2 of them. I've got some like terms to combine. There's a 7x plus a 3x. That's going to be a 10x. So we'll just say plus 10x. And then finally, we have my constant term, just the number without the x, the negative 5. I'm going to check that off again to make sure I'm not missing anything. Minus 5. All right, I'd say that this polynomial is now in standard form. The degrees decrease from left to right, starting at the highest, ending with the constant term or the lowest degree. Okay, all my like terms are combined. I combined all the x to the fourths, x to the thirds, x squareds, x's. Okay, and again, it's going to be a little bit easier to work with our polynomials in this form. All right, that's part A. There's also a part B in your note guide. Why don't you take a minute, pause the video, work through part B, okay, give you a chance to practice what we just did here, and then before we move on to the rest of the video, shoot a hand up, get your answer checked. Let's make sure you're good with that part before we move on. Next thing we're going to do in problem 2 is look at adding polynomials together. So it says simplify each sum, write the answer in standard form. So what I want to do here is I want to combine these two polynomials, my 2x to the fourth minus 3x plus 9, with my x to the third plus 12x. Okay, I want to put those together, combine all my like terms, and put them in a standard form. Okay, now really all the parentheses are doing for me on this question is helping me see which two polynomials I'm talking about. Okay, otherwise I can just start putting together my like terms like I had a minute ago. Okay, I've got my greatest degree, the 2x to the fourth, and once again there's no other x to the fourths. And again, I'm going to check that off as I go. Okay, the next up I've got the x to the third. We'll say plus x to the third. Okay, we'll check that off. I'm not seeing any x squared terms, so we'll skip that term. Okay, and then the x's, looks like there's multiple x's once again. Okay, that's not always going to be the case, but just happens to work out that way for these last two. Okay, we've got a negative 3x to the third plus 12x. Did I say to the third? I meant just negative 3x. Negative 3x plus 12x is going to be a 9x, positive 9x. And then finally we have the plus 9. I'd say looks like we're good, looks like we're done with our sum. We're in standard form. We've combined on like terms. I'd say that addition problem is done. Okay, pretty similar to what we just did a minute ago, but slightly different way to think about it. Once again, there's a part B in your note guide, so take a minute, pause the video, work through that, and then get your answer checked before we move on. Again, let's make sure we're understanding this and practicing this stuff as we go. In problem 3, we're looking at subtracting polynomials. So same idea, simplify the difference this time and write the answer in standard form. Now the only difference I have between this problem and my last one is I have subtraction between my two polynomials. And I actually have the same numbers here. It looks like I copied and pasted and actually forgot to switch the stuff up. That'll be okay though. Now for the subtraction, these parentheses are going to matter. The first way I can rewrite this is by distributing this negative, okay, the subtraction of both the x to the third and the 12x for this one here. Okay, so my first step is just going to be to rewrite the whole thing as 2x to the fourth minus 3x plus 9 minus x to the third minus 12x. And the big trick or the big kind of thing to watch for as you're doing subtraction is making sure you're distributing to the entire polynomial that you're subtracting. And then from there, it's just a matter of combining my like terms to put things in standard form once again. I've got my 2x to the fourth. All right, this time I've got my minus x to the third. And then once again, like we've seen a whole bunch, I'm going to combine my x terms. So I have a negative 3x and a minus 12x. They'll be minus 15x. And then last thing I have is my constant term, my 9. So we'll say plus 9. All right, there we go. There's our subtraction, okay, with our polynomial now in standard form. And again, the big thing is make sure that when you're subtracting a polynomial, you distribute that negative to the entire thing. Once again, there's a part B. Take a minute, pause the video, work through that, and check your answer before you move on. In problem 4, we're going to start taking a look at multiplying polynomials. And we'll have a few different examples of multiplying just to cover the few different combinations of different types of polynomials we can multiply together. Okay, so in 4, I'm going to say I have a monomial, okay, single term polynomial, times another type of polynomial. In this case, it's trinomial. And the way we'll make multiplication work is we're going to take our monomial and we're going to multiply it by all 3 parts, okay, or all the parts of whatever polynomial we're multiplying by. Okay, so we're using our distributive property here to make this happen. Okay, so 4 squared times 3x to the third. Now remember, to combine exponents with the same base, what we'll do is we'll add the exponents together. So I'm going to say this is a 3x to the 5th power, okay, because 2 plus 3 would be 5. And then we'll multiply the x squared times the negative 2x squared. That's going to give me a negative 2. And x squared times x squared will be x to the 4th. And we'll do the third multiplication. X squared times 8, we can just say is plus 8x squared. Okay, so there's multiplication using my distributive property. Now, take a minute, make sure after you've multiplied that the polynomial is still in standard form. Typically, if you're multiplying polynomials that start in standard form, a lot of times they will be in standard form just by distributing. This one looks like it's good, so I'd say we're done with this one. All right, part B is just another example of multiplying a monomial times a different type of polynomial. Take a minute, pause the video, work through that, and then check your answer before you move on. Next problem we're going to look at is multiplying a binomial times another binomial. Okay, so 2 terms times 2 terms. Okay, and this will be a procedure that shows up a ton as we move forward. Okay, and essentially the way I need to make this happen is I need to take everything in the first polynomial and multiply it by everything in the second. I can think about using my FOIL acronym, if you've heard that. I'm going to multiply the first 2 numbers together for F, the outer numbers for O, the inner numbers for I, and the last 2 for the L. Okay, if that acronym helps, cool, use it. But if not, we'll just, again, multiply everything in the first by everything in the second. Okay, so for the first part, we'll take a 2x times 3x for the first. Okay, 2 times 3 is 6, and x times x is x squared, so we'll call that a 6x squared. Next, we'll do the outer, 2x times negative 7. We'll call that a negative 14x. Then we'll do the inner for the I. 4 times 3x will just be a 12x, so we'll say plus 12x. And for the L, the last from our FOIL, we'll go 4 times negative 7, which will be a negative 28. Okay, we've done the multiplication. We've distributed everything in the first polynomial times the second. And then once again, you want to take a look and make sure everything is in standard form. Okay, it's not here yet. I can combine my like terms for my outer and my inner. Okay, the negative 14x plus the 12x is going to be a negative 2x. So we can finish this one off by writing it as 6x squared minus 2x minus 28. All right, there's my polynomial in standard form now. Once again, there's a part B that's going to give you a shot to practice this. Take a minute, pause the video, work through that one, and then check your answer before you move on. All right, next multiplication problem we're going to look at is going to be multiplying a binomial, 2 terms, by a trinomial, 3 terms. And we could keep extending on this. We could do trinomial times trinomial, or a trinomial times a 4-term polynomial, and so on and so on. The pattern is going to work out the same, but we'll say this is as difficult as we're going to make it. But essentially, the idea here is going to be multiply everything in the first polynomial by everything in the second polynomial. Okay, we don't have a fancy acronym for binomial times trinomial, but it's the same idea as the FOIL method. We're going to take the 2x from the first polynomial and multiply it by all three parts in the second. So let's go ahead and do that. 2x times the 3x squared is going to give us a 6x to the third. Then we'll go 2x times the x, which will give me a 2x squared. And then the 2x times the negative 5, which will give me a negative 10x. Okay, so we have the first term of the first polynomial times everything in the second polynomial. Now we'll just do the same thing with the second term from the first polynomial. Negative 7 times 3x squared is going to give me a negative 21x squared. All right, negative 7 times x is going to give me a negative 7x. And then negative 7 times negative 5 is going to give me a positive for negative times negative. And 7 times 5 would be 35. Okay, so plus 35 at the end. Okay, so we've got the multiplication done. We've distributed one polynomial across the other. Now we've got kind of a mess going on here. Okay, like usual, put things in terms of standard form. I've got a 6x to the third, which I will check off to make sure I'm not missing anything. For x squareds, I've got a positive 2x squared and negative 21x squared. Putting those together will give me a negative 19x squared. We then have a negative 10x and a negative 7x, which you can combine as a negative 17x. And then last thing, our constant term, we've got the plus 35. All right, so there's my polynomial, all multiplied out in standard form. Okay, once again, like usual, take a minute, pause the video, go ahead and work through part B in the note guide, and get your answer checked before we move on. In problem 7, we're going to look at a special multiplication case. Okay, again, simplify the product, and this time I've got x plus 8 all squared. Now, it might be tempting here just to square the x and square the 8, but that's not what we have here. Remember, when we're squaring something, what we're actually doing is multiplying it by itself. So the way I can rewrite this x plus 8 squared is I can write it as x plus 8 times x plus 8. So in other words, binomial times binomial. Okay, using my FOIL method, I can multiply these together and simplify this one, just like we did a few minutes ago. Okay, for the f, we'll do the first. X times x will give me x squared. For the O outer, we'll do x times the 8, which will be a plus 8x. For the inner, we'll go 8 times x again, which will be plus another 8x. And then last, we'll go 8 times 8 for 64. And simplifying that, okay, we can combine our like terms on our x's and finish this off as x squared plus 8x plus 8x will be a 16x, and then plus a 64. All right, there you go. That's the trick for squaring a binomial. It's really just that binomial times itself, and for that we'll distribute using the FOIL method once again. Okay, again, take a minute, pause the video, work through part B. Make sure you get your answer checked before we move on. And the last thing we're going to work on for the next few problems is going to be factoring polynomials. Okay, basically factoring is undoing the multiplication we've just been working on for the last few problems. Okay, for certain applications, you're going to want to be able to write your polynomials in standard form, but in other cases, you want to have them in factored form. Okay, so we want to be able to work on both. Let's work on some factoring here. Okay, so if I want to factor this trinomial, what that's going to turn into is a product of binomials, okay, two binomials being multiplied together here, where we can think about kind of having two slots to fill in, the first number for each binomial and the last number. And we'll talk you through this process. There is a little bit of guess and check, there is a little bit of trial and error here, but we'll kind of help you simplify that. Now, to get the x squared, that's going to come from multiplying the first terms together. And the only way to get an x squared nicely is just to multiply x by x. So I know I've got that right off the bat. And then the 24 is going to come from the last terms being multiplied together. And the negative 11x would come from the outer and the inner added. And I know if I want to multiply to a negative number, but multiply to a positive number, but add to a negative, I know the sign for both these last terms is going to have to be negative. Okay, now what I need to do is I need to look at my different factors of 24. I'm going to list them here. Okay, I can multiply to 24 by going 1 times 24. I could also go 2 times 12. Whoops. I could go 3 times 8. I could go 4 times 6. Okay, so I need to figure out which combination is the right combination here. So I need two numbers that multiply to 24 but also add to 11. Well, my winners are going to be the 8 and 3. So I can write this as x minus 3 times x minus 8. That's going to be my factored form. And the reason I know that works is if I multiply things back out and check, if I go x times x, I'll get my x squared. If I go x times negative 8, I get the negative 8x. Negative 3 times x will be negative 3x. And negative 3 times negative 8 will give me my positive 24. Okay, so I've got the x squared. I've got the 24 that we started off with. And then if I combine the negative 8x and negative 3x, we get a negative 11x. Okay, yep, so we got that middle term as well there. Okay, I probably made that look pretty easy. Okay, I've been doing that a bunch. Again, there is some trial and error. What I'm doing in my head here is I'm kind of checking through which of these combinations are going to make this problem work. Let's do one more of these as a class before we give you a chance to try a few. Okay, so I want to factor this x squared plus 2x minus 15. Okay, again, that is writing it as a product of binomials. To get the x squared, we'll keep things simple. That's going to be an x times an x. Now, to get the negative 15, I know my last two terms are going to have to be one negative and one positive. And it doesn't matter what order you leave them in. I'll just go x minus and x plus. And then what I need to do is I need to look at my factors of 15. Okay, well here I could have 1 and 15 or 3 and 5. And that's it. I just need to figure out which combination of these will work. Well, I need the one that's going to have a difference of 2. So I've got to go with the 3 and 5 here. And it has to be a positive number, so I know that the 5 is going to have to be the positive part, and the 3 will be the negative part. All right, there's my factored form. And once again, I can check things by going x times x will give me an x squared. X times 5 will give me plus 5x. Negative 3 times x will give me a negative 3x. And those will cancel to give me the positive 2x. And negative 3 times 5 will give me a negative 15. Yep, it checks out, so I know I factored things correctly. Okay, you've got a couple of practice problems in the note guide, a part C and a part D. Definitely want to give you a chance to practice the factoring. This will probably be the tricky part of this lesson. So take a few minutes, pause this video, work these ones out. Okay, shoot a hand up to check your answer or shoot a hand up if you have questions. And again, we made this look kind of simple, but there's some guess and check work here, so don't feel bad if you try something, okay, multiply it back together and not get the right thing. Okay, well if that's the case, if I try something that doesn't work, I know I can eliminate that option before I move on and try another one. Next thing we'll do is start looking at a few special cases of factoring. Okay, the first one in problem 9 is I'm going to say is the difference of squares. Okay, I have something squared, in this case x squared, minus something else squared, which 16 is a 4 squared. And I'm going to say anytime I have a difference of squares, I can just write my answer as this. I can say it's the first thing minus the second thing. Okay, the first thing that was squared minus the second thing that was squared. Okay, times the first thing that was squared plus the second thing squared. Okay, I'm going to say this is my factored form here. And the reason it's going to work is if I FOIL things back together, x times x would give me an x squared, x times 4 would give me a 4x, negative 4 times x would give me a negative 4x, and negative 4 times negative 4 would give me a negative 16. Okay, anytime I have this pattern, the inner and the outer parts are going to cancel out. Just give me that x squared minus 16. Okay, so the trick for this is just recognizing that when I have this difference of squares, I can just write it with the minus and the plus pattern that you see here. Okay, when you remember that pattern, pretty simple. Okay, part B will give you a chance to practice that, so quickly take a minute, pause the video, work through part B, and again, get your answer checked before we move on. And the last problem we're going to look at quick is just factoring by factoring out a greatest common factor. Okay, for this one, if I want to factor it, it's not a trinomial. Okay, so I can't do my reverse FOIL. And also, it's not my difference of squares pattern, so I can't use that pattern. But I can still pull these apart and make it a little simpler. What I can do is I can look at the factors that are common between both these terms. Well, both 4 and 20 are divisible by 4, so I can pull that out. And then also both these terms have an x in them, so I can pull that x out as well. And I can rewrite this as 4x times what I'd have to multiply 4x by to get this original polynomial. Well, 4x times x will give me the 4x squared. And then plus 5, if I distribute 4x times 5, that'll give me the 20x. Okay, so that's factoring by pulling out the greatest common factor. Okay, kind of undistributing whatever's common between these two terms here. Okay, one more time, work through part B of this part of the note guide. Okay, and that's actually it for the video. So once you get your answer checked for that, you're free to move on to the Math Excel practice. Do check your answer though. Do make sure you're doing this stuff right before you move on.